Welcome to Bridge Academy. 5. The History of Computing. Deciphering Cryptographic Messages. Introduction. The history of computing includes many milestones that shaped how we process information today. One key figure in this history is Abu Yusuf Yaqub ibn Ishaq al-Sabah Al-Kindi, a 9th century scholar known as the Philosopher of the Arabs. His work on deciphering cryptographic messages, or cryptanalysis, was a groundbreaking step in computational thinking. By developing methods to break encrypted codes, Al-Kindi showed how logic and analysis could solve complex problems. This section explores Al-Kindi's contributions to cryptanalysis, focusing on his techniques and their impact on the history of computing. In the 9th century, people used encryption to protect sensitive messages. Encryption relied on two main methods: transposition and substitution. Transposition involved rearranging the order of letters or words in a message. Substitution replaced letters with others, creating a coded message. With 26 letters in the English alphabet, these methods produced countless combinations, making encrypted messages seem secure. Without knowing the specific encryption technique, decoding was thought to be nearly impossible. However, Al-Kindi, a scholar from Basra, Iraq, changed this belief with his innovative approaches to breaking codes. Al-Kindi was a brilliant thinker who excelled in many fields, including mathematics, linguistics, medicine, astronomy, and music. Educated in Baghdad, he wrote over 290 books and became the director of the House of Wisdom. This institution was a hub for learning, where scholars translated Greek texts from the Byzantine Empire. Among these texts were encrypted messages created for kings, generals, and politicians. Al-Kindi saw these coded documents as a challenge. He used his knowledge of mathematics and linguistics to develop ways to decipher them, even without knowing the encryption method. Al-Kindi's breakthrough came from using statistical analysis, particularly letter frequency analysis. He noticed that in any language, certain letters appear more often than others. For example, vowels like E and A are common in English. By studying the frequency of letters in an encrypted text, Al-Kindi could identify patterns. He also used trial decodings, guessing probable words or vowel-consonant combinations to unlock the message. These methods allowed him to decrypt messages quickly, often in minutes. His techniques were revolutionary because they showed that encrypted messages were not as secure as people believed. Al-Kindi recorded his methods in a book titled A Manuscript on Deciphering Cryptographic Messages. This book was the world's first treatise on cryptanalysis. It was also one of the earliest works to describe statistical techniques in writing. Al-Kindi's approach laid the foundation for modern cryptanalysis, which is critical in computing and cybersecurity today. His work demonstrated how combining different fields, like mathematics and linguistics, could solve complex problems. This interdisciplinary approach is a key part of computational thinking, which is central to the history of computing. Sadly, Al-Kindi's book was lost for centuries. It was rediscovered in the 1980s at the Süleymaniye Ottoman Archive in Istanbul. In 1987, the Arab Academy of Damascus published it, allowing modern scholars to study Al-Kindi's methods. His work remains significant because it showed how data analysis could reveal hidden patterns. By breaking encryption methods thought to be unbreakable, Al-Kindi proved the power of logical and systematic thinking. His contributions influenced later developments in computing, as they highlighted the importance of analyzing information to solve problems. Summary: Al-Kindi's work on deciphering cryptographic messages was a major milestone in the history of computing. His use of statistical methods, like letter frequency analysis, allowed him to break encrypted codes quickly. His book was the first to document cryptanalysis and statistical techniques. As director of the House of Wisdom, Al-Kindi combined mathematics and linguistics to solve complex problems. Rediscovered in the 1980s, his work continues to inspire modern computing and cybersecurity. Al-Kindi's legacy shows how early scholars used innovative thinking to lay the groundwork for today's computational advancements. Thank you, like, share, and subscribe.